Hello and welcome. We are going to work today on solving equations and inequalities. We're going to start with some one-step equations, and then ultimately our goal is going to be able to solve two-step equations and then to solve and graph two-step inequalities. So we're just going to start with a quick definition, and you can copy this down into your toolkit, but we're going to talk about inverse operations. So inverse operations kind of like undo each other. So for example, if I pick any number, so pick any number that you want to pick, and then if you were to add 2 to that number, and then I were to say to you, okay, get back to the original number, what would you do? You would subtract 2, right? So those are called inverse operations. So for example, if I started with like 5, and I said 5 plus 2, okay, that's 7. Well, if I now want to start at that 7 and get back to that 5, I have to subtract 2. So adding 2 and subtracting 2 are inverse operations, and then multiplication and division are inverse operations as well. So if I start at, let's say, 10, and I multiply by 3, I get 30. And then if I want to get back to that 10, I would divide by 3, right? So we use what we know about inverse operations to solve equations. And we're going to start with one-step equations. So this part of this should be review, but the other thing you need to know is that when you solve equations, whatever you do to one side, you have to do the other side. Equations are balanced, and you're allowed to do whatever you want to both sides of the equations as long as you do the same thing to both sides. So first I can start by thinking of splitting the equation at the equal sign. So I have like two sides, like the left side and the right side. And I want to get the variable by itself. I want to get x by itself. Right now, x is not by itself. I'm starting with x, and then I'm subtracting 4 from that. So I want to use my inverse operations. How do I get back to just x? Well, if I add 4, right, subtracting 4 and then adding 4 cancel each other out. Negative 4 plus 4 is 0. In other words, I'm back to just x. But here's the thing. If I add 4 over there on the left side, I have to add 4 on the right side as well. And so x is equal to 6. And the other thing that hopefully you remember you can do is when you're solving equations, you can check your answer to make sure you got the correct answer by taking this value for x and plugging it back into the original equation. So like 6 minus 4 equals 2. And so 6 minus 4 does equal to 2, and 2 is equal to 2. Because when I plug in, that makes that equation true, I know that I got the right answer. So let's try number 2. Again, I can think of splitting the equation at the equal sign. Here's the x. That's what I want by itself. Well, what am I doing to that x? I have that x, and I'm adding 3 to it. So to undo the inverse operation of adding 3 is subtracting 3. And I can think like, oh, 3 minus 3 is 0. So this is just x. But I have to subtract 3 over here as well. So negative 9 minus 3 is negative 12. So x equals negative 12. Down here, number 3, negative 7x means negative 7 times x. So I'm multiplying. The inverse of multiplying is dividing. So I can divide both sides by negative 7. Negative 7 divided by negative 7 is 1. Or in other words, they kind of cancel out, and I have like 1x. But when I just have 1x, I don't need that 1. That's really just x. And so negative 21 divided by negative 7 is positive 3. Number 4, remember if you have like a fraction like this, x over 4, that really means x divided by 4. So x divided by 4 equals 2. The inverse operation of division is multiplication. So I'm going to multiply this side by 4, or in other words, like 4 over 1. And I have 4x over 1 times 4 is 4, right? Well, what's 4 over 4? 4 over 4 is 1. So I have 1x, or in other words, just x. But when I multiply the left side by 4, I have to multiply the right side by 4 as well. So 2 times 4 is 8. So x is equal to 8. Notice all of my answers are x equals. And, the x could be on the left or the right. Doesn't matter which side, but my answer isn't just 8, it's x equals 8. So those are all called one-step equations because we did one step. We added, we subtracted, we multiplied, divided in order to get our solution. So now we're going to talk about what we call two-step equations. So a two-step equation is going to look like this. And just like it sounds, it's going to require 2 steps in order to solve. And eventually we're going to get to solving like different types of equations, 3-step equations, equations with variables on both sides, all different stuff. But in order to get good at those other types of equations, we need to be good at these 2-step equations as well. So we're going to split the equation in half, just like we did with the one-step equation at that equal sign. Now, when we get the variable by itself, let me look at the variable. Here's the x. What am I doing to the x here over on that right side? It's 2x minus 2. This means like 2 times x, and then I'm subtracting 2. So I'm multiplying and I'm subtracting. Now here's the thing. We solve equations basically in the reverse order that we simplify expressions. So when we say simplify an expression, you think like PEMDAS, right? When we solve an equation, we think SAD MEP. So you're going to do your subtractions or additions first, and then your divisions or multiplications. So PEMDAS is simplifying, SAD MEP is solving equations. So you can see down here, step 2. So we're going to isolate the variable or get it by itself by adding or subtracting the constant first. So we're going to get rid of this -2, this minus 2 part here. In order to undo subtracting 2, minus and 2, we're going to add 2 to both sides. So the -2 plus 2 cancel out. And then 10 plus 2 is 12, right? So we have 12 is equal to 2x. But now I need to get rid of that like 2x or 2 times x. So the inverse operation would be to divide by 2. And then 12 divided by 2 is 6. My final answer, it says it has to be in the correct form, meaning it has to be like x equals 6. Can't just be 6, right? So there you go. You just solved a 2-step equation. Let's try, we're not going to do everything here together. I'm going to try a few with you, and then you're going to go back and do the rest on your own. But let's just try, we'll start with number 13, okay? So here's number 13. First, figure out, where's the x? Here's the x. What am I doing to that x? I'm multiplying it by 2, and I'm adding 1, right? Here's the equal sign, so I can split that equation kind of like in half. Now, remember, SAD MEP. I got to do my subtractions or my additions first. So multiplying by 2, adding 1, we got to get rid of that adding 1. So we're going to subtract 1 because 1 minus 1 cancels out, gives me 0. But I also have to subtract 1 on the other side of the equal sign. So 7 minus 1 is 6. So I have 2x equals 6, right? Now, I want to get x by itself. I can divide both sides by 2. X is equal to 3. And I could check my work, like we said before, by plugging in. So I'm going to take that 3 and plug it in wherever I see an x. And now if I simplify, I use order of operations, PEMDAS. I got to multiply first. 2 times 3 is 6. 6 plus 1 is 7. 7 equals 7. I got the right answer. Okay? Let's do one like this here, number 17. So now the s is over on the right-hand side of the equal sign, right? Doesn't matter. And I also noticed that it's like -s. Well, what's in front of an s or an x or b or whatever variable? If I just have like regular old x, it's not, it's not that there's nothing in front. It's not that there's no coefficient. There's an invisible 1. So if I have like -x, it's a -1x, right? So this here in number 17, this means like -1s. So we have -1 times s plus 9. To get the s by itself, we're going to do our addition or subtraction first. We're going to minus 9. 4 minus 9, -5. So -5 is equal to -s. That's a 5. And then it's really like a negative 1s, right? I want to get rid of that negative 1 because I want s by itself, not negative s. Divide both sides by negative 1. Negative 5 divided by negative 5 is positive 5. 5 is equal to s. So it doesn't matter if the variable is on the left or the right side. You're always going to follow this same process. Okay? All right. You try a couple more of these, and you can always check answers with the answer key provided. So you can pause the video now, try some practice problems, and check your answers. We're going to try, now that you've done a bunch of those two-step equations, we're going to try to do some more, but now you're going to notice these have fractions. But don't let this scare you. We're still going to follow the same process that we did before. Let's start with number 22. So we draw a line down the middle of the equal sign, and I find my x. Here's the x. That's what I'm solving for. That's what I want to get by itself. If I look at this equation, this means like x divided by 2. Remember, a fraction is really division. So it means x divided by 2, and then we're adding 3 as well, right? So I got to get rid of my addition or subtraction first. So we're going to subtract 3. So 3 minus 3 is 0. That cancels out. Negative 9 minus 3, negative 12. So I have x over 2 equals negative 12. And remember, x over 2 is really x divided by 2, right? The inverse operation, or the opposite of dividing, is multiplying. And I showed you this before, but I'm going to remind you. If I multiply by 2, that's like 2 is a whole number. I'm multiplying by a fraction. So I got to make 2 like 2 over 1. Multiply the numerators. That's like 2x. And the denominators, 1 times 2 is 2. And then 2 over 2 is really 1. So I just have x, right? So that's why multiplying by whatever you divide by, or in other words, what's in the denominator, is going to cancel out in the denominator. But here's the thing. If I multiply right here by 2, I have to multiply the other side by 2 as well. Negative 12 times 2 is negative 24. So my final answer there, x is equal to negative 24. All right, we're going to do 2 more problems together. So let's do this one right here. 23. So here's my equal sign, right? So I find what I'm trying to solve for. Here's the x. That's what I'm trying to get by itself. What am I doing with that x? I have x divided by negative 8, and then I'm subtracting 27. So if I want to use inverse operations, I'm going to get rid of subtracting 27. So I'm going to add 27 to both sides. And be really careful here. I have negative 30 plus 27. Use your calculator if you want to or you need to. Negative 30 plus 27 is negative 3. Over here, this cancels. And so I have x over negative 8 equals negative 3. Now I need to get rid of, remember in a fraction, that means like x divided by negative 8. I need to get rid of that dividing by negative 8. So to get rid of dividing by negative 8, I got to multiply by negative 8. So I got to multiply this side by negative 8. So negative 8 divided by negative 8 cancel out. They give me 1. So I just have x equals, and a negative times a negative is a positive. 3 times 8, x equals 24. Okay. Let's do one more problem. Let's jump down to, let's say, like number 25, just because the variable is now on the right-hand side. But it all kind of still works the same. So there's the m. That's what I'm trying to solve for, right? I have m over 4. In other words, m divided by 4, and then plus 2. I get rid of that plus 2 using inverse operation. So I'm going to subtract 2. 2 minus 2 cancels out because 2 minus 2 is 0, right? I don't need that plus 0. 10 minus 2 over here is 8. And I have m over 4. And so m over 4 means m divided by 4. I need to get rid of that dividing by 4. I'm going to multiply by 4 on both sides. Dividing by 4 and multiplying by 4 cancel each other out. So m is equal to 4 times 8 32. All right, try the rest of those. And again, you can check your answers with the answer key provided. You can pause the video at this point. All right, let's review some inequality symbols. So you're probably familiar with these, but I'll tell you that it's going to really benefit you later on down the road when we get to solving different types of inequalities if you know what these are called. And I always remember learning that like when the inequality is facing the same direction a capital L is, so if I just like write a capital L and then kind of like rotate it, that's the less than sign, right? So right there, that's less than. And then if it has the little line underneath it, this means less than or equal to, right? And then this one facing the other direction means greater than or greater than or equal to. So pause the video a quick second, write this down in your toolkit so that you have these definitions down, and then we'll solve some inequalities. All right, so what does this say in words? This says x is less than 7, or in other words, x is a number. A number is less than 7, right? So how do we graph it on the number line? Well, think about like what numbers could work for x. These numbers have to be less than 7. So it could be 6, it could be 5. 0 is less than 7, right? Negative a million is less than 7. Negative 10 is less than 7. Any negative number is less than 7, right? So to graph this on the number line, we kind of start at 7 and we would shade everywhere below. And we would want this to go all the way down to negative infinity. So we put like that arrow on the end. But here's my question. What about like where does this stop over here on the right hand side? Where does it stop? Does it stop at 6? Does it stop at 7? Because 6 certainly, 6 here is less than 7. But isn't 6.5 less than 7? Isn't like 6.8, 6.9 less than 7? So we want to kind of go all the way up to the number 7, but we don't want to include 7 because 7 is not less than 7. So we use what's called an open circle. So we put an open circle at the number 7, and that means that this kind of like shaded region goes all the way up to 7, but it does not include 7. So it includes like 6.99999999999, right? But not 7. So what if it were x is less than or equal to 7? Then that would be a number is less than or equal to 7, right? So then I would want to include the 7. I could shade this circle in. We call this a closed dot or a closed circle because 7 is a solution now. So we would start at 7 and go everything to the left of it. Here's an important note, and I would maybe write this down in your notes. Anything that is shaded is a solution to the inequality, and anything not shaded is not a solution. So in other words, all these numbers down here that we have shaded in this portion here, they're all solutions. If I plug in any number for x, it makes that inequality true. But anything that's not shaded, for example, 8, 9, 10, 7.5, 7.1, those weren't shaded in my graph. So if I plug them in for x, it would make the inequality false. And the same idea with like the open circle. We set up here with x is less than 7, I would use an open circle. In other words, the circle isn't shaded in. But if it's x is less than or equal to 7, we would use the closed circle so it's shaded in. It is a solution. All right? Okay, so jot down these steps. You can pause the video if you want to. But when we solve inequalities, they're going to be real similar to equations. We're going to use inverse operations to isolate the variable. Get the variable by itself just like we would if it were an equal sign. But here's the thing. Anytime I multiply or divide with a negative number, you have to flip the inequality sign. So in other words, if it started with a less than, you flip it to a greater than. If it started with a greater than or equal to, you flip it to a less than or equal to. So you flip the direction it's going. And again, that's only if you multiply or divide by a negative number. It doesn't mean if my answer is negative, I flip. No. Only if I multiply or divide with a negative number. And then I graph as well. If you need to pause this here and write these steps down, feel free. All right, let's try some examples. So here's number 1. We want to solve and graph. So we have x is greater than or equal to -1. That's already solved for x. X is by itself because here's where I would kind of divide the inequality into 2 parts, and x is already by itself, right? So I don't have to do anything to solve. I'm just going to graph. So I always start with a number line, and I start at 0. And I don't have to label, if this were a number line, this would be 1, 2, 3. I don't have to label all these. I just kind of start at 0, and then I'm okay, here's -1. So it says x is greater than or equal to -1. So always the numbers that are greater than another number are always going to be to the right. So for example, 0, 1. And I would include -1 because of this or equal to part. So I use a closed circle, and then I would shade to the right. So that's my graph. All right, number 2. So I'm solving for x. Splitting at the inequality. I have -2 times x is less than 10. So I need to divide, because this is multiplying, -2 times x. I'm going to divide by -2. Now, here's the thing. Because I'm dividing by a negative number, this should ding, 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 sawed off bells in your head. We have to flip the inequality. So this cancels. I have x, and then instead of a less than, it turns into a greater than. And then 10 divided by -2 is -5. So that's my solution. Here's my number line. Here's 0, 1, 2, 3, 4, 5. There's -5. I want where x is greater than -5. So greater than, where a number is bigger than -5, those would be all to the right here. Those numbers are all bigger. I put an arrow at the end indicating that really my solution goes on to infinity. And the -5 would get an open circle because -5 is not greater than -5. It should not be shaded. It's not a solution. Let's try number 3. So here's the x. We have 3 times x, so we're going to divide both sides by 3. 12 divided by 3 is 4. I divided, but I didn't divide by a negative number, so I do not flip the inequality. So I have x by itself. I put 0, 1, 2, 3, 4. When I graph, right? Now, be very careful because the x here in this case is on the right-hand side of the inequality. And a lot of times people mess up the graphing when the x is on the right-hand side. So I'm going to show you 2 options. I can either graph it as is. I'll show you that now real fast. So this says 4 is greater than x. So what kind of numbers? Think about what kind of numbers I could plug in to make this true. 4 is greater than what? If I plug in let me write this up here. 4 is greater than or equal to, let's say 10. Is that true? Is 4 greater than or equal to 10? Nope. So 10 is over here to the right of 4, right? So let's try a number to the left. How about 4 is greater than or equal to 3? Is that true? Yeah, 4 is greater than or equal to 3. So any other number to the left, 4 is greater than or equal to, how about -5? That is true. So I want to start at 4. 4 gets a closed circle. and I'm going to shade to the left. If that's a little confusing for you to graph it that way, what you can do is when you solve, if your variable's on the right-hand side, you can flip and put your variable on the left. So, but here's the thing. If you flip the inequality, the whole thing has to flip, including the inequality symbol. So I started with 4 is greater than or equal to x. If I flip it, I flip the whole thing. It should be x is less than or equal to 4. All right, let's do a couple more. So number 4, here's my inequality. I have x plus 6. So I need to get the x by itself. Inverse operations, I subtract 6. 8 minus 6, 2 is less than x. So I can circle it and graph it from here if I'm okay. So here's 0, 1, 2. If I'm okay with graphing when the variable's on the right. If you want to flip, remember you flip the whole thing. Put the x on the left, the 2 on the right, but I have to flip the inequality symbol as well, right? So these two things mean the same thing. So the 2 gets an open circle, and x is greater than 2. So a number has to be bigger than 2, so we would shade to the right. All right. How about this one? Let's get x by itself. Negative 3x means negative 3 times x. Inverse of multiplication is division. We're going to divide both sides by negative 3. Because I'm dividing, I'm flipping the inequality, so it turns into a less than. And then 9 divided by negative 3 is negative 3. So there's my solution. So here's negative 3. Negative 3 gets an open circle because it does not have like an or equal to. And its x is less than negative 3. So less than a number always is going to go to the left. All right, number 6. This is a 2-step inequality. So here's my line. Again, remember SAD map, I'm doing my addition or subtraction first, and then my multiplication or division. So it's negative 4 times x plus 3. Let's get rid of that minus 3. So I have negative 4 less than or equal to 6 minus 3 is 3. Or negative 4x, sorry. Negative 4x less than or equal to 6 minus 3, which is 3. Now, I subtracted 3. Subtracting 3, even though it's like, there's a minus sign, does not make the inequality flip. But now to get x by itself, I have to divide both sides by negative 4. I'm dividing by a negative number, so I have to flip the inequality symbol. So x is greater than or equal to, 3. I can't do 3 divided by 4. That doesn't go in even, so I leave it as a fraction. I'd reduce it if I could, but I can't reduce that. And then when I graph it, negative 3 over 4 is like, if here's 0, here's negative 1, negative 3 over 4 is right there. That gets a closed circle, and x is greater than or equal to that, shades over to the right. All right, here's some more practice problems. I'm going to actually do one more of these with you because we didn't do one like this number 10. So I'm going to do one more of these with you, and then you can do the rest on your own. So we want to get the x by itself. Here's the x. X divided by 4, because a fraction is division, right? To undo dividing, we're going to multiply both sides by 4, And I'm multiplying, but I'm multiplying by a positive number. The number I'm multiplying by is 4. And 4 is positive, right? So I do not flip the inequality. And negative 2 times 4 is negative 8. So my solution, x is greater than negative 8. So here's negative 8. Negative 8 gets an open circle, and x is greater than, shades to the right, because all these numbers to the right, like negative 7, negative 1, 0, a million, they're all bigger than negative 8, right? Okay, thanks for watching. There's some more practice problems here that you can try. And again, like we said before, you try these and then check your answers with the answer key provided. And I think you'll be good to go after this with 1- and 2-step equations and inequalities. Thanks so much for watching. Have a great day.